On October 18, 1989, the Space Shuttle Atlantis lifted off, carrying with it the spacecraft Galileo, which was set to explore the planet Jupiter and its moons. NASA's original plans were to use the Centaur propulsion system, which utilizes liquid hydrogen and liquid oxygen as propellant, to provide a direct trajectory to intercept Jupiter. However, following the Space Shuttle Challenger disaster, safety mandates would force the craft to use a less effective solid rocket alternative, which led to a change in flight path that would necessitate 3 gravity assist flybys, 1 by Venus and 2 by the Earth. These close encounter flybys use the gravity of the planets to accelerate the orbiter to the necessary velocity to travel to Jupiter. The earlier Pioneer and Voyager probes fueled a desire to get a better understanding of Jupiter. Studies of the atmosphere's chemical makeup, as well as radiation emissions and magnetic fields, were among the top of the mission's list. In addition to Jupiter, Galileo was to study its moons. Detailed mapping and various forms of imagery scanning were performed on the moons Europa, Ganymede, Callisto, and Io. Numerous systems for scientific study were incorporated into the design. Magnetometers and dust detectors would study the magnetic fields at various distances from the giant planet, as well as detect the charge of particles as small as 1 micrometer. Plasma analyzers and energy particle detectors were also implemented into the design. Magnetic flux would be measured using a heavy ion counter, and positioning and attitude calculations were performed using a star scanner, which provided a frame of reference. Ultraviolet spectrometers were used to scan a wide range of the ultraviolet spectrum, along with a high-resolution multispectral camera to capture details of the composition of Jupiter's atmosphere. Mapping of mineral distribution was possible with a device capable of near-infrared image acquisition. Radiation emission and solar reflection was observed using a photopolarimeter radiometer. Powering the various operating systems and functions was a pair of radioisotope thermal generators. Using the nuclear decay of plutonium-238, both electrical and thermal power were provided. The RTGs provided the electrical power required by the systems to function and thermal heat energy to maintain an operational temperature range in an otherwise frigid and harsh environment. Upon reaching Jupiter, the orbiter deployed the Galileo probe, which descended toward the planet's surface and began taking measurements of temperature, pressure, density, and atmospheric chemical composition. The probe observed tremendous pressures, as well as thunder and windstorms which belittled any found on Earth. The probe confirmed that the composition of Jupiter is primarily made of hydrogen and helium, as is our Sun, and it is believed that the inner reaches of Jupiter may actually be hotter than the Sun's surface. As the Galileo probe plummeted deeper toward the center of Jupiter, it never communicated the existence of any solid surface. After 78 minutes of descent, transmissions from the Galileo probe ceased. On September 21, 2003, the Galileo spacecraft entered the atmosphere of Jupiter at over 100,000 miles per hour and was destroyed, ending a long, successful exploration of the Jovian system.